Okay, we're going to start a little section on related rates, and related rates will end up being um, kind of these story problems where you look at them and you say, there's no way I can get this answered, but then through a little calculus, you arrive at the answer. So it's kind of the stereotypical math story problem. So let's take a look at this. In fact, why don't you pause the video and read that little scenario, and then we'll talk about how we use that to label. Okay, so a lot of information there. Basically, what's happening is the wind is blowing the kite that way, and the person wants to keep tension on the string, so they're going to have to wind the string that way. And it also says the kite is maintaining a constant height, so that means it's not really going up over here. It's not really going up or down. So what we have to do is we have to take that information and we have to label our triangle situation here. So I see that this thing forms a right triangle, which is going to be a clue for us later that we're probably going to use Pythagorean theorem. But let's not worry about that right now. And for each one of these sides of the triangle, you want to get 3 levels of labeling if you can, and I'll explain what that means. First thing is just your basic algebra lettering. So this distance is a left and right distance, so it's very smart to use x because that's what you're used to seeing in math. And this distance right here is an up and down distance, which is normally a y value in math, so go ahead and use a y. This is the hypotenuse, so you could use an h. If you use an h, you sometimes mix it up with a height, so I think I'm going to use a z to represent hypotenuse. Go with whatever you want. So that's our first level of labeling. Now, all of these sides also have number values. So some of them are easy and straightforward, like it tells us the kite is at 200 feet. So I'll put a 200 there for y. And, oh no, it doesn't. It tells us it's at an altitude of 100 feet. Scribble that out. But the kite is 200 feet from where this person is standing. So that's where the 200 goes. Now they didn't give us the hypotenuse, but we can figure that out using the Pythagorean theorem. So I'm going to pause the video and write that out. Okay, so I worked that out on the side, but basically I said side squared plus side squared equals hypotenuse squared. And I found out what our z is, and you'll notice that I went to mini decimals because, as you know, don't round early in a calculus problem because you have to be accurate to 3 decimals at the end. All right, so now each one of these sides has 2 levels of labeling, a letter and a number, a letter, number, a letter, number. But I mentioned that we need 3 levels of labeling, if possible, in a related rates problem, and that 3rd level is calculus. So let's think of it this way. The kite is being pulled in this direction, so this distance x is shortening at a certain rate. In fact, we know that rate. It's shortening at 3 feet per second. So that is calculus. The dx dt equals -3. dx dt says x is changing over time. 3 is the rate. And because this is shortening, I need a negative. If x were getting longer, then I would need a positive. Let's move on to the y. Y is representing the altitude of this kite, and it says that the altitude is constant, somewhere in here, right? It's at a constant altitude of 100 feet. So what I will do is I will say dy dt, the change in the y value over time, equals 0. And finally, we look at this side, and we want to know at what rate is the string being wound in. So this string is being wound in. That is the value, or the letter z. And so what we found out is we are looking for the dz dt. So a big part of your Pythagorean theorem problems are take all of this information, and if you can, do 3 levels of labeling. 1, 2, 3, 1, 2, 3, 1, 2, 3 for each side. It's not always possible, but you should strive for that. Okay, so you got the first part done. You have the labeling done. Now the next part is you look at this situation and you daydream about your math past, because there's going to be some equation from your math past that applies to this scenario. In this case, I bet you figured out that the famous equation from your math past is the Pythagorean theorem. So I'm going to write that down. And from here on out, we're going to use information from here as we do some calculus and algebra gymnastics on here. I'm going to pause the video and write this out and then come back and explain it. Okay, we're back. So this was the equation that we had drawn from our math past that relates to the situation. And once you have that equation, you've got to take your derivative, but it has to be with respect to time, because all of this scenario is playing out over time. You kind of should take that hint because they talk about feet per second and things like that. And so when I do that derivative with respect to time, be very careful here. The derivative of an x squared is a 2x. I just took the derivative of an x term with respect to time. Same thing there with respect to time. Same thing there with respect to time. Once you have that equation, now you can go back up to your diagram and start plugging in values. For example, I know x is 200. I know dx dt is -3. Well, you can do that for all of those pieces of information except for this one, dz dt. But you know what's awesome about that? That's the one thing that we're looking for in this problem. So your equation is psychic. It knows what you're looking for. You're looking for dz dt. Now you're in the world of Algebra 1. Just solve for dz dt. And you have it. So the big picture is this. Read your scenario. Label the heck out of it, going 3 levels of labeling for every part of your diagram if you can. Can't always do that. Select an equation from your math past that represents the situation. Take its derivative with respect to time. Fill in information from the diagram. And by algebra, you will get your answer. I hope you enjoyed it.